Hey boys and girls, Mr. DiGiovanni here. In this video we're going to continue to work with fractions. Two goals that you have for this video, and I'd like you to copy them down. One is to evaluate a reciprocal, and the other is to solve algebraic equations that involve fractions. So copy those down and then continue on to the next slide. So reciprocal very simply means to flip the fraction. All right, be sure to copy that down into your notes. Copy down these instructions, find the reciprocal for each number, and I got a few examples here for you. I'll go through the first one with you just to guide you. First one is 3/5. So all we're going to do is we're going to flip the fraction. So whatever's in the numerator will go in the denominator, and whatever's in the denominator will just go up into the numerator. Okay. So our final answer, which you should write on your paper, would simply be 5/3. Okay. Really simple. So for letter B, again, just flip the numerator and denominator. And as you know, it really doesn't matter which of these gets the negative sign in the numerator or the denominator. But make sure it goes into one of them. Don't put it into both. Okay. If you wrote -7 over +4, that also would be fine. Take a look at letter C. We just have a whole number here. So we're talking about flip the fraction, find the reciprocal. So make it into a fraction. Okay, now we can easily flip this. The reciprocal of 8 is simply 1/8. Okay. Using the reciprocal will be helpful for us as we solve certain types of algebraic equations involving fractions. Let's move on from this. So we've met one goal, hopefully. Copy this down. Example number 1, solve the equation to determine the value of the variable. So let's copy the equation down here, and we'll work from here. So we know in order to solve for a variable, we have to isolate the variable or get the variable alone, and we do so by doing opposites. So on the left side of the equation, where the variable is, we're subtracting -1/5. So let's do the opposite, and we will essentially add 1/5 to both sides. Okay, so x minus 1/5 plus 1/5. And we'll do that to both sides. So bring down the -7 over 15. We'll add 1/5 to both sides. What you do to one side, you have to do the other. You guys should know that. All right. On the left side of the equation, -1/5 plus 1/5, well, that cancels each other out. So all that remains is x, and that's exactly what we're hoping for. On the right side of the equation, we've got to get a common denominator. You guys know that. So it should be pretty clear to see our common denominator should be 15. So the first fraction can stay put, -7 over 15. And then the second fraction here, we're going to multiply top and bottom by 3. So it would be plus 3/15, excuse me. All right. So really what we're left with is -7 plus 3, which would give us -4. So our answer here would be -4 over 15. Don't forget to bring down your variable. So x equals -4 over 15. Woo. Awesome. All right. Let's take a look at the next one. All right. Copy this down. Example 2. All right. Solve the equation. 4n equals -8 over 11. Again, we got the variable on the left side. We want to isolate it. So think about what operation is being done to the variable. Well, here the variable is being multiplied by 4. So we're going to do the opposite. We will divide both sides by 4. Okay. So let's divide this side by 4. Here, I'll tell you what, let's rewrite this. The second step first. Okay, so we got 4n divided by 4 equals -8 over 11. And notice we're dividing by 4 here, so we're going to divide by 4 over here as well. It goes right in the denominator. Okay. Over here, 4 over 4 is essentially 1. So we're left with 1n or n. And over here, we've got -8 over 44. Right? Because we're going to multiply on the bottom these two numbers. And we're dividing by 4. If that confuses you, another way to think about it, Now if we just work over here, we got negative 8. Well, that's an 8. Okay, over 11 divided by 4. Right? And if we make 4 into a fraction, it's really 4 over 1. Yes, and then we know how to divide fractions. Okay, some of you may like this way better right now. Okay. If you look, it's really the same thing. Negative 8 over 44. Okay. This is an even answer though, so we got to reduce it down. We can cut them both in half. If we cut 8 in half, we get negative 4. And we cut 44 in half. We get 22. And they're both still even. So we can cut them in half again. So let's say we'll go slide right over here. N equals negative 2 over 11. Okay. And hopefully that makes sense. So there we go. Ta-da! All right. Let's move on. Let's take a look at example 3. Here we got, here's where we're going to use the reciprocal. So negative 2y, negative 2 sevenths times y equals negative 3. So again, we got to get y alone. Here we have a fraction times the variable. Fraction times the variable. The easiest thing we can do once we identify this is to simply multiply both sides by the reciprocal. And if you think about reciprocal, we're talking about flipping the fraction. Okay? So come on back here. Let's flip this fraction. If we flip this fraction, it's basically negative 7 over 2. Okay? Times negative 2 over 7y equals negative 3. And then what you do to one side, you got to do to the other, right? So, negative 7 over 2. Right, so the green is what we did to both sides. Over here, these are going to cancel out. Negative times negative is positive, and all this is going to equal 1 times y, positive 1 times y, which is just simply 1y over y. So we've isolated the variable here. That's exactly what we want. It's not a good looking y, but you guys get the point. All right, over here, we can make negative 3 into a fraction, and then we just vroom it. Negative 3 times negative 7. Negative times negative is positive, so positive 21 over 1 times 2 is 2. Ta-da! And that's what we got. Okay? So, final answer, 21 over 2. Ta-da! Okay? So remember, when you have a fraction times the variable, right, simply multiply both sides by the reciprocal. All right, let's try one more final example here. You guys, hopefully you keep it up. If not, you guys can go back and replay this on your own. You can help each other out here. So take a look at this one. Example 3. How about example 4? I don't know why I mislabeled that. Sorry. Example 4. Ta-da. All right. So here's our variable. We got to isolate it, right? So we haven't really gotten too much into these. These are what we call two-step problems, but we're going to get into these, and you guys are pretty smart. So let's take a look at it. We want to work furthest away from the variable. So the 2/3 is being multiplied by it. The 12 is a little further away from it. It's being added, subtracted to it. So we'll work with that first. Let's get rid of that one first. Let's get to our regular pen here. So let's do minus 12 to both sides. So if we subtract 12 on both sides, right, 12 minus 12 is going to be 0, which just leaves us with 2/3 times x on the left side. All right, on the right side, we got negative 19 minus 12. Same sign, so combine those and keep the sign. It's going to be negative 31. All right, we don't have the variable alone quite yet, but if you look, this is eerily similar to this problem here. Right, where we've got negative 2/7. We got a fraction times a variable. Well, look here, we got a fraction times a variable. So if you know what to do, let's see, we've got to work that reciprocal. Flip that fraction. Fraction times a variable, flip that fraction. So the reciprocal 2/3 is simply 3 over 2. And times 2/3 x. That's going to cancel out those fractions for us. That's exactly what we want. That's going to help us isolate the variable. Negative 31 times 3 over 2. And what you do to one side, you do to the other. Okay. So on the left side, it's going to cancel each other out. We got 1x or x. And over here, let's make 31 into a fraction. All right, 1 times 2 is 2. That's the denominator. That's easy. 31 times 3, well, I can kind of do that one. It's going to be 93. Don't forget your negative sign there. Okay, so negative 93 over 2. 2 is even, 93 is not. We cannot reduce that. Not the prettiest looking answer, but it is correct. So we'll circle that and we'll go with it. Ta-da! All right, get some flowers on that one. So hopefully you guys are able to follow that one along. It's a tricky one. We're not quite there yet, but somebody I think can get it fine. Hopefully this helps you guys. Refer back to these notes as you do your practice problems. Thanks for listening.